10.1, example 4. In this example, we're going to determine the length of one arc of a cycloid. So recall from the last video that a cycloid looks something like this, and it repeats over and over. And what we're going to want to do is go ahead and find the length of one arc regardless of what A is. We have the two equations, x equals a times t minus sine of t, and y equals a parenthesis 1 minus cosine. So the first thing we're going to do is we're going to write down the equation for arc length. And we know arc length is the integral between t1 and t2 square root dx dt squared plus dy dt squared and dt. So we need to find each piece. We're going to have to find t1, t2, dx dt, and dy dt. So recall from the last video that each arc is t equals 2 pi times a. Now for our t1 value, it's just going to be 0 because that's where we're going to start the arc. So our second t value is 2 pi because that's how long it takes for the circle to do one revolution. So now we got to find dx dt and dy dt. Well, I know that x is equal to a parenthesis t minus sine of t. So then dx dt is going to be a parenthesis 1 minus cosine. And then I need to square it because in the equation under the square root, I need this squared. So I get a squared 1 minus cosine of t squared. So this is going to become a squared 1 minus 2 cosine plus cosine squared. And now we need to find dy dt. So we know that y is equal to a 1 minus cosine. And so I know that dy over dt is going to be a sine of t. And then I need to square it. So dy dt squared is a squared sine squared of t. Now that I have all the pieces, all I have to go ahead and do is plug it into my equation. So now that I've gone ahead and plugged everything in, I'm going to simplify. I notice that both terms have an a squared, so I'm going to go ahead and factor that out. And then within the integral, I have a cosine squared plus a sine squared, so that's going to equal 1. And I'm going to go ahead and bring that a squared out as just an a, because remember a is just a number. So I get 1 minus 2 cosine of t plus 1. Simplify that just a little further. I can bring the a out of the integral because it's a constant. 2 minus 2 cosine of t dt. And then what you're going to want to go ahead and do is plug this part of the equation into the calculator, and you end up getting 8. So then we get L is equal to 8a. So if we know what a is, we can actually find the length of each arc just by using this little formula.